What if I told you the universe has a place so dangerous that even time is afraid to move forward there? A place where light tries to escape and fails. Imagine a massive star shining for millions of years, suddenly losing its fight against gravity. No explosion, no mercy. Just collapse, everything falls inward, endlessly. Space bends, time slows. And reality breaks. Scientists call it a black hole. But that name doesn't even begin to describe it. Because this isn't just an object in space. It's a cosmic trap. Once you get close, the universe itself pulls you in. And the scariest part, we still don't know what lies inside. Today we open the darkest chapter of the cosmos, and it starts here. To understand a black hole, we have to travel back to a time when it didn't even exist as an object, only as an idea. Long before telescopes could see deep into space, scientists were already asking a dangerous question. What happens if gravity becomes so strong that escape is impossible? In the 1700s, thinkers imagined dark stars, objects so massive that light itself would fall back onto their surface. It sounded impossible until physics caught up. This strange idea slept quietly for centuries, waiting for someone to rewrite the rules of gravity itself. And that moment came in the early 20th century, with one revolutionary theory that changed how we understand the universe forever. That revolutionary moment arrived in 1915 when Albert Einstein introduced his theory of general relativity. Einstein showed that gravity is not just a force, it is the bending of space and time caused by mass. The heavier the object, the deeper the bend. When scientists applied Einstein's equations to extremely massive stars, the result was shocking. The math predicted a point where space-time curves infinitely inward, a place where density becomes endless and known physics collapses. Even Einstein struggled to believe it, but the equations were clear. Something like a black hole had to exist, and once that door was opened, there was no closing it. At first, scientists thought this strange result was just a mathematical illusion. Even Einstein believed nature would somehow prevent such an extreme object from forming. But as research continued, the evidence became impossible to ignore. In the 1930s, physicists realized that if a star were massive enough, no known force could stop its collapse. Gravity would win completely. The star would shrink beyond any limit, crushing itself into a point of infinite density. This terrifying conclusion gave birth to a new concept, the singularity. A place where space, time, and the laws of physics as we know them simply break down. And from this idea, the true fear of black holes began. But why do we call it a black hole? The name wasn't invented until the 1960s, when scientists needed a term that captured its terrifying nature. It's not a hole you can fall into, and it's not empty. It's a region in space so dark, so powerful that nothing escapes, not light, not matter, not even time itself. The name stuck because it's perfect, a cosmic prison with a heart of infinite density. But understanding the name is one thing. Understanding how a black hole forms is another. And to do that, we need to look at the life and death of stars. Every black hole begins life as a star, but not just any star. Only the most massive stars, at least 20 times heavier than our sun, have what it takes. Inside these giants, two forces battle constantly. Gravity pulls everything inward, trying to collapse the star. At the same time, nuclear fusion produces an outward pressure, pushing against gravity. This delicate balance can last millions of years, keeping the star stable. But like all battles, it eventually ends. When the star runs out of fuel, the outward pressure drops to zero, and gravity finally wins. Once the star's fuel is gone, gravity doesn't just win, it takes over completely. The star begins to collapse under its own weight. Its core shrinks, matter compresses, and density skyrockets. The collapse doesn't stop until the star has been crushed into a point of infinite density, the singularity. Around it, space itself bends, forming an invisible boundary called the event horizon. Anything that crosses this line, whether matter or light, is trapped forever. This is the moment a black hole is truly born, a cosmic monster with gravity so strong nothing can escape. Not all black holes are the same. They come in different sizes and powers, each with its own story. Stellar black holes are the most common, born from single massive stars collapsing. Then there are supermassive black holes, millions or even billions of times heavier than our sun, sitting quietly at the centers of galaxies, including our Milky Way. And somewhere in between lie the mysterious intermediate black holes, the missing link that scientists are still hunting for. Each type behaves differently, but all share the same terrifying feature: gravity so strong it bends space, traps light, and twists time itself. To understand a black hole, we need to look at its structure. At the center lies the singularity, where density becomes infinite and physics as we know it breaks down. Surrounding it is the event horizon, the point of no return. Cross it, and escape is impossible. Outside this boundary, some black holes are surrounded by a glowing accretion disk formed by gas and dust, spiraling inward at incredible speeds. This disk shines brightly, sometimes outshining entire galaxies, giving us the only visible clue that a black hole is lurking in the darkness. A black hole's gravity is unlike anything we experience on Earth. It doesn't just pull, it hunts. Anything that comes too close is dragged inward, no matter its direction or speed. Even light cannot escape this cosmic grip, which is why black holes appear completely dark. And the closer you get, the stronger this pull becomes, bending space and time around it like a warped funhouse mirror. Gravity here doesn't just attract, it controls reality itself, making black holes some of the most extreme objects in the universe. But gravity isn't the only strange thing about black holes. Near the event horizon, time itself slows down. To an outside observer, someone falling toward a black hole would appear to freeze, moving slower and slower as they approach the boundary. Yet for the person falling in, time feels completely normal. This isn't science fiction. It's a real effect predicted by Einstein's theory of relativity. Near a black hole, gravity doesn't just pull matter, it bends the very flow of time, creating a cosmic paradox that's almost impossible to imagine. And it gets even stranger. Scientists have long wondered, what actually lies beyond the event horizon? Could it be a doorway to another universe? Could information survive the fall, or is it lost forever? Inside a black hole, the laws of physics as we know them completely break down. Matter, energy, and time behave in ways we can't fully predict. This is the ultimate cosmic mystery. A place where reality itself becomes uncertain, and imagination meets science at its limits. One of Interstellar's most powerful scenes shows a team landing on a planet near a black hole. Down there, severe gravity means 1 hour equals 7 years in orbit. After facing disaster with giant waves and spending just a few hours on the surface, they return to their ship. They are shocked to find their lone crewmate, who they left behind, has aged 23 years while waiting for them. It's a gut-wrenching depiction of Einstein's theory of relativity made real. Despite all we've learned, black holes remain one of the universe's greatest mysteries. They shape galaxies, influence stars, and hold secrets billions of years old. Observing them from afar gives us glimpses into the deepest laws of physics, yet their core, the singularity, remains hidden, unreachable, and unknowable. They challenge our understanding of reality, time, and even the nature of existence itself. And that's why, even after decades of study, black holes continue to captivate, terrify, and inspire both scientists and dreamers alike. So what does all this mean for us, standing here on Earth, gazing at the night sky? Black holes are reminders of how small we are, and yet how powerful curiosity can be. They are both destroyers and creators, shaping the cosmos in ways we are only beginning to understand. Every discovery brings new questions. Could we ever travel near one? Could we harness their energy or glimpse another universe? The truth is, black holes are far more than cosmic monsters. They are the ultimate teachers, showing us the limits of space, time, and human imagination. And perhaps the most fascinating question of all is this: what happens if you actually fall into a black hole? According to current physics, once you cross the event horizon, escape is impossible. You would experience spaghettification, stretched and torn by gravity, while time around you continues normally. To an outside observer, you'd appear frozen at the edge, never truly disappearing. It's a one-way journey into the unknown, a place where space, time, and reality themselves are twisted beyond comprehension. This is the ultimate frontier of the cosmos, and it continues to challenge everything we know about the universe. So here we are, Back on Earth, looking up at the night sky, knowing that somewhere out there, black holes are silently shaping the universe. They are invisible yet powerful, terrifying yet fascinating, destroyers yet creators. They bend space, twist time, and challenge everything we know about reality. And the truth is, we still don't know what lies inside. Maybe another universe, maybe the absolute end. But one thing is certain. Black holes are the universe's ultimate mystery. And as long as humans keep watching, dreaming, and exploring, we'll continue to unravel their secrets, one discovery at a time. The darkness is vast, the mystery is deep, and the journey has only just begun. If you enjoyed this journey into the darkest secrets of the universe, don't forget to hit that like button, subscribe to the channel, and ring the bell so you never miss an adventure. Trust me, the universe has a lot more to show, and the next cosmic mystery will blow your mind even further.